So if you want to build a 20 LED chaser circuit using some CD4017s, two of them, a 555 timer, a bunch of LEDs, and a total of 4 resistors and 2 transistors, you can. It's fairly easy on a, well, I'm going to take that back. It's not kind of easy. It's a real pain in the neck soldering. You'll notice why in a second. There's the underside. But it's a cute little project, and it has some quirks. So at whatever time is in the corner here, I'll go through the schematics, and then at that time there, I will go through building it. I'm going to fast forward through the building, and partway through I kind of went, this is too irritating, and then I just wired it up off camera. And then at whatever time's left over there, I'll explain what the little quirk is with this. Now, knowing that there's a little quirk with it, keep an eye on when I go through the schematics, which I actually taped earlier. So, on to the first part. Hopefully I just demoed the LED chaser. But when I was looking at it, I looked at the initial Texas Instrument design for chaining the CD4017s. We'll ignore the timing part because that'd be the same in both circuits. This is not the circuit I used, and I'll show why. First off, the first chip, other than the fact that you need an extra AND gate, but on the first one, okay, Q0 comes up fine, you go through, but you can't use Q9 for an LED because it's needed to inhibit the chip and also enable the clock to go to the next one. Well, then on the next one, well, you can't use Q0 because it would have lit up right off the bat as soon as you fire up the circuit. So you have Q0 going to the reset of the next one in line. So on this one here, all you get is 8 LEDs that you could use for it, or 8 outputs for LEDs, because again, you need Q9 to go down to, ignore this here, it would be an AND gate, and that enables it going across to the other next chip. And on that one, well, again, you can't use Q0 because you're actually going to use it to reset back this way. And you can't use, that was Q9 going back. And you can't use Q0 because, same reason for here, it would have lit up as soon as you fired up the whole circuit. So, you get 9, 8, and 8. Well, that's not the most efficient way to do it. You've now got 3 CD4017s. You've got an AND gate chip. So now you're up to 4 chips. Well, this is a much better way of doing it. Okay, your clock is the same as the previous one. But here you just need 2 CD4017s, and then you use just transistors. So as this one's stepping through, this cycle over here, or this one over here, is just going to keep cycling back and forth, back and forth. It doesn't care about the rest of the world. It just keeps on going. But when it hits the 10th, it does the carry out. And you put that into the clock for this one. So initially it's going to start on Q0, which is powered up. But after this clicks over, after one cycle through, it then advances it to the next one, which would be pin 2, which is Q1. This one gets turned on, that one gets turned off. So you basically just have the LEDs coming out, 2 of them coming over, one bank of them, 10 of them for the one, and the other 10 for this one. Much simpler. This is going to be much cheaper to make also, because you only need 2 CD4017s, no AND gates, and you could keep expanding this one. You could expand it up to, well, probably about 9 or 10. Now, on this one, since you're only going to do 2 on, or I'm only doing 2, on pin 4, which is Q2, you click it over to pin 15, which is the reset. So then it just cycles again and again and again. So that's the design I'm using. Now it's time to put it together. So here's the working diagram, mimicking what kind of like what the board's going to look like. You have the first one. It's doing all the wiring out to here. You have one set here coming across. So on the anode, it comes over. I've got my limiting resistor here, transistor here, then down to ground, and it's controlled by the second CD4017. Then once it switches over, the next one, another transistor, limiting resistor. It's just going to cycle again, and these ones will light up. And then around and around it goes. So time to put it together. I'll probably fast forward through the assembly. Oh, for the clock, I'm picking values like 8.2K for RA, 100K trim pot for RB, so you can set the speed. And the capacitor is 4.7 microfarad. By the time I finish, things might be changed a tiny bit. So here it is all wired up. Went a lot quicker once I did the soldering and not having the camera in the way. This one here, this row here, is for this transistor, which is coming off of pin 3, which would be Q0. And this row here is off of Q1, which is pin 2. Goes through a 1000 ohm resistor to the transistor, which is a BC337, and then I just stuck a 330 ohm resistor between there and the ground, well, not the ground, but the anodes. So that's what it looks like on the far side. So one side I just strung it over, then this would go to the transistor, and on the other bunch of LEDs I ran it like that also. And then I went from each of those nice little pins over here to the appropriate ones here to put them in order. So that's what it looks like. As I say, it went a lot faster once I quit going bang into the camera, bang into the camera. So did you figure out what the quirk is? Well, it's not guaranteed to start up properly each time, but given a few cycles, it then gets back working fine. And that's because in here on the circuit diagram, this is the reset pin. It's not set to ground, so it doesn't start in a known condition. So this here is Q2. What happens if it fires up and it's at Q3? Well, it's going to do Q3, Q4, Q5, Q6, Q7, Q8, Q9, and then it's going to set this one and then start working properly. Now, to show that, it's pretty random. Okay, I lucked out. It'll get there eventually. There we go. So right now it's a Q9, and now it's over to Q0. So that transistor there's fired up, then this one fires up. So it works. It's got a little quirk in it. It's a livable quirk. Have a good day. Bye.